Hello everyone, welcome back to Civil Learning online YouTube channel. As we were learning partial fraction, which is very important to learn before we start learning inverse Laplace transformation. So here we go, and this is third type of numerical problem which we may face while solving the partial fraction in Laplace transformation, inverse Laplace transformation. Here you can see this is quadratic equation type of numerical, and I have already discussed about the first two type, that is when the denominator has linear factor, second one is when the denominator has the repeated linear factor, and the third one is denominator has quadratic form. So here we go, and this is first example, so I am going to solve this here. So learn the concept here, how to solve when we face the quadratic form of quadratic form in the denominator. So without any further delay, let's get started. So you can see that here in this problem, that is here we have one factor, that is x square plus x plus 1, which is in the form of ax square plus bx plus c, and it is quadratic equation. So whenever we face this type of question, what we need to do is we have to remember that when the denominator contains a quadratic factor, we have to consider the possibility that the numerator can contain a term in x. Okay, so this is because if it did, the numerator would still be of lower degree than the denominator. This would still be a proper fraction. So what we do, what it says, that we have to consider whenever we come to face any problem in which one of the factor is of quadratic form, then what we have to do, we have to assume that there is still a constant which has the multiple of x in numerator, which will still make the function this fraction will still be a proper fraction, because the proper fraction are those fractions when the variable x has the highest highest degree in the denominator than in numerator. You can see here we have 5x upon x square plus x plus 1 times x plus minus 2. So we have to consider that it is ax plus b upon x square plus x plus 1 plus c upon x minus 2. Why so? See here, here the highest power of the denominator x in denominator is 2, and here still if we write 1x, also the power of denominator is lower, so it is proper fraction. It will still be proper fraction. It is initially it is proper fraction, and after adding x also it will remain in proper fraction. But there is fourth type in which we will discuss about how to solve the improper fraction, in which you can see that the numerator, the highest value of x in numerator has the higher degree than in denominator. Denominator, see x when get multiplied with x, here the power will be 2, so the degree is 2, and here the degree is 3, so it is improper fraction. So we will also learn how to work with improper fraction, and here we are learning about the quadratic equation factor. So here this will get written as this form. Now we will proceed further. So again the step is same like what we have done in the previous example. So we will multiply both sides with the denominator. This denominator will get multiplied on both sides, so we will have here 5x equals to ax plus b times, and remaining value is x minus 2, because when this will multiply with this, so x square plus x plus 1 will get cancelled out with this, so we will have x minus 2 plus c times x minus 2. When this whole term is get multiplied with this, so x minus 2 get cancelled out, so we will have here x square plus x plus 1. Now let's do the multiplication like we were doing earlier. So we will have here, when ax is multiplied with x, we will have here ax square plus b will multiplied with x, we will get bx. Okay, similarly we have minus 2 will get multiplied with ax, so we will have here minus 2ax and minus 2b plus cx square plus cx plus c. C is multiplied with each coefficient of each and every term here in the bracket. So we will have here 5x equals to, and take coefficient of x square common, x square, take x square common from both, so we will have here a plus c times x square, and we have now x remaining, so we have 3x, and the coefficient which we take x common from them, then we will have here plus minus 2a plus b plus c times x, and finally we will have here plus minus 2b plus c, because we have one term in which there is no any coefficient. Now we will equate on both sides. See here there is nothing, means we can rewrite it as 0 times x square plus 5x plus 0 times this term which had no any variable. So on equating this both side, we can rewrite it as, on comparing both side, we can rewrite it as a plus c equals to 0, and like we did in the numerical earlier, if we put x equals to 2, in this equation, this is equation 1, and if we put x equals to 2 in this equation, then this term will get cancelled out, because 2 minus 2 will get 0, and so this becomes 0, and we can find the value of c from here. See, if we are putting, if x equals to 2, so we will have here 10, 5 times 2 is 10 equals to, this will get 0 plus c times, and 2 square is 4 plus 2 6 plus 1 7, so we will have here c equals to 10 upon 7. So from here we will have a plus 10 upon 7 equals to 0. From here we will have a equals to minus 10 by 7. ठीक है. Now we have successfully calculated the value of a and c. Now we need to find the value of b. So we can write it as, see here this is a term which has no any variable, and this is the term which has no any variable, so we can rewrite it as minus 2b plus c equals to 0, and we know the value of c is 10 by 7, so minus 2b plus 10 upon 7 equals to 0, or minus 2b equals to minus 10 upon 7, 2 times 5, and minus will get cancelled out, so we will have here b equals to 5 upon 7. So we have successfully calculated the value of a, b and c. Now we will rewrite the equations. Therefore the required partial fraction is required fraction, partial fraction is a is minus 10 upon 7. So minus 10 upon 7, we are putting the value in this equation. So 10 upon 7 times x plus b is 5 upon 7 upon x square plus x plus 1 plus c is 10 upon 7 x minus 2. We can rewrite, take 1 by 7 common, so we will have here, and we can take 5 by 7 common here. So 5 upon 7 can be taken as common from here. So we will have here numerator will be 1 minus 2x upon x square plus x plus 1 plus 10 upon 7 times x minus 2. Now let's see one more example on this method type, that is when the denominator has quadratic equation. So guys, as you can see, here is example 2, and you can see here we have x square plus 1. You can see that x square plus 0 times x plus 1 equals to 0, and this is in the form of ax square plus bx plus c equals to 0. So this is again quadratic equation. Now let's say learn its solution. So we can rewrite it as, right here, solution and 13 upon 2x plus 3 times x square plus 1 will be equals to, I'm going to rewrite it as ax plus b upon this term first, x square plus 1. You can do this because both are in multiplication, plus c upon 2x plus 3. Now you are smart enough to solve this numerical like I have done the example question number 1. So again the step is same. We are about to do the multiplication on both sides with the equal value of denominator. So we will have here 13 equals to ax plus b times remaining term will be 2x plus 3 plus c times this, again the remaining term will be x square plus 1. Now what we can do, we can put x equals to minus 3 by 2. Put x equals to minus 3 by 2. If we put x equals to minus 3 by 2 minus what I said, this is 2x plus 3, and we put x equals to minus 3 by 2 and plus 3. So 2 and 2 gets cancelled out, and minus 3 plus 3 will make it 0. So this term will get 0, and we will have here 13 equals to 0 plus c times minus 3 by 2 square will be 9 by 4 plus 1. So on solving further, we will have 13 equals to 9 by 4 plus 1 means 9 plus 4, and here nothing means 1. So LCM will be c times 4 and 4. LCM will, denominator will be 4 on taking LCM of both, and 9 plus, here let me to show you this in rough. So we have 1 upon 1, and we take LCM. So LCM is 4, and 9 plus this 1 4 times will be 4. So and this numerator is 1. So 1 is multiplied with 1 4 times 4. 1 times 4 equals to 4. So we have 9 plus 4 is 13 by 4. So 13 by 4, and this 13 and 13 gets cancelled out. So we have c equals to 4, because here c is in division and here we have 1, and so this will get multiplied. So it will get c, we will have c equals to 4. Now again what we will do, we will do the multiplication in equation 1. So from equation 1 we will have here 13 equals to, do the multiplication, 2a x square plus 2b x plus 3a x plus 3b plus c x square plus c. Now we will take the commons here. So taking x square common, we will have 2a plus c times x square plus, take x common, so we will have here 2b plus 3a times x plus 3b plus c. Now we need to equate on both sides. So from here we can have on equating this and this, or we can equate this also. We can equate any, because here we have 0 times x square plus 0 times x plus 13. Okay, so we can take 2a plus c equals to 0, and we have calculated the value of c. So 2a plus 4 equals to 0. From here we will have a equals to minus 4 upon 2, so a equals to minus 2. Now we have got the value of a and c. Now let's calculate the value of b. So we can use this term, that is 2b plus 3a equals to 0, and we have 2b plus 3a, and we are to calculate the value of b. So 2b plus 3 times minus 2 equals to 0. So we will have b equals to minus 6. Sorry, this minus will get converted to plus on moving on the other side of equal to. So 6 divided by 2 will be 3. So I am going to write one line here. Therefore required partial fraction is, what is the partial fraction? Ax, a means minus 2x plus b is 3 upon x square plus 1, and value of c is 4, so plus 4 upon 2x plus 3 is required answer. You can rewrite it as 3. You can rewrite one more step, that is 3 minus 2x upon x square plus 1 plus 4 upon 2x plus 3. So you can leave up to here also, or you can write one more step, that is up to you. So see you in the next video. Till then, stay safe and take care of yourself.